Good morning, calculus class. This is Miss G. It is Tuesday, April 21st. I hope you're all doing well. Today, we're going to work on section 5.4. We've been in section 5.4 for a while now, but there's lots of good stuff in 5.4. Our general topic was area and the fundamental theorem of calculus, and our specific topic for today is the average value of a function. So let's look at the definition of average value. If a function f is continuous on the closed interval ab, then the average value of f on the closed interval ab is, here's our formula, 1 over b minus a times the integral from a to b of f of x dx. Now, the formula might look a little complicated, but you know how to do everything in the formula. They're going to give us a closed interval with values for a and b, so we're just going to plug in a and b here, and then as our limits of integration here, we'll find an antiderivative for f of x, and then we'll use the first fundamental theorem of calculus, and we have a definite integral, so we'll find the antiderivative, and we'll plug in our upper limit first, our lower limit second, and subtract, and then multiply that result by 1 over b minus a. All right, let's see. It'll become clear with an example. There's the formula, here's the example. Find the average value of f of x, which equals x squared. That's our function. That's going to be our graph on the closed interval 0, 4. So I'm asking you to graph it tonight as well, and I did that here. And so we only need to graph it from 0 to 4. So here's 0 to 4 along the x-axis. These are x values. And we're graphing x squared. If you need a little help with any of the graphs tonight, just put them in your calculator, see what they look like. So from 0 to 4, there's our parabola. What we want is the average y value. We want to know which one of these y values is the average for all of these y values here. Well, this is a continuous function. We can't find every one of these points added up and divided by the number of points, like you would do if you had test scores. If you had your test scores, you could add up all your test scores, divide by the number of test scores, and find your average test score. Those are discrete points, separate values. They're not continuous. You can't have a test score of 18.456. So what we do here to find an average y value of a continuous function is we use our formula. And our formula is 1 over b minus a times the integral from a to b of f of x dx. So let's apply it here. Our a and our b are 0 and 4. So we get 1 over 4 minus 0 times the integral from 0 to 4 of x squared dx. X squared is the function. And now we find the antiderivative of x squared. We add 1 to the exponent. We get x cubed. We divide our coefficient by the new exponent, gives us 1/3. So our antiderivative of x squared is 1/3 x cubed. We multiply by 1/4 and we get 1/12 x cubed. We're going to evaluate it from 0 to 4. We plug in our upper limit first by the fundamental theorem of calculus. So we get 1/12 4 cubed, and we subtract what we get when we plug the lower limit in, which is 0. So minus 1/12 0 cubed. This gives us 1/12 64 times 64 minus 1/12 times 0, and we get 64 twelfths, which is 5 4/12, which is 5 1/3. That is our answer. That is our average y value. Now let's see if it's a reasonable y value. Let's look at our function. Our highest y value was 16. Our lowest one is 0. If we add 0 and 16 and divide by 2, our average comes out 8. Well, that would be great if this was a line, a linear function. But we have a curve, it bends here. So it brings our average down a little. But 5 1/3 is still between our lowest y value and our highest y value, and it's reasonable because our curve bends a little. So our average y value is 5 1/3, which is about here, right about there. Okay, let's do another one. Find the average value of f of x equaling 3x squared minus 2x on the closed interval 1 to 4. So first what you're going to do tonight is you're going to graph this on 1 to 4. So I did that. Here's my graph of this function. Again, you can use your calculator if you want to see what it looks like and you don't want to plot points or use your intuitive sense. All right, so our lowest y value is 1, 1. Our lowest y value is 1, and our highest y value is 40. If we average those, we get 41, so 20.5, maybe you would think 20.5 is going to be your average value, but again, this is not a line. Some people argue curves are lines are curves, but we're going to say our curve is bending here, so our average might be a little lower than 20 something, a little lower than that, right? Okay, so let's take a look and let's do it. So here's our formula. We plug in our 4 and our 1 over 4 minus 1 times the integral from 1 to 4 of our function, and then we find our antiderivatives. The antiderivative, we subtract. We simplify this. 1 over 4 minus 1 gives us 1/3. All right, now we find our antiderivatives. And so the antiderivative of 3x squared is x cubed. The antiderivative of 2x is x squared. And I know you know how to do that with the power rule. So now we're going to evaluate it from 1 to 4. So fundamental theorem of calculus, we plug 4 in first, we plug 1 in second, and then we subtract. And we simplify this. We'll get 1/3 of 64 minus 16 minus 1/3 of 1 minus 1. That gives us 1/3 of 48 minus 1/3 of 0, which ends up being 16 minus 0, or 16. So our average value does fall between 1 and 40, and that would be 16. All right, so there you go. I hope you followed that. I do have an assignment. It's from section 5-4, page 349, numbers 53, 54, and 55. I gave you the answer to 54 because it's even. The answer is 10. But my directions are a little bit different from the ones in the book. They don't tell you to sketch the graph. I want you to sketch the graph. So please sketch the graph and then find the average value of the function on the given interval, just like we did here. They also ask you to do one other thing, but I'm not asking you to do that. So you do not have to find the x values for which the function is equal to its average value. You don't have to do that last part in their directions. Okay, and if you have any questions, send me an email. I hope you have a fabulous day. Take care.